It was the night of the 13th of April, 1993, when the sky began to roar with an unknown fury. In a matter of minutes, the darkness transformed into a monster of lightning and unleashed winds. No one knew it yet, but that would be the most violent night in the meteorological history of the Southern Hemisphere. More than 100 tornadoes, from timid columns to devastating funnels, would descend upon Buenos Aires with terrifying synchronicity. Some call it the night of 100 tornadoes. And today we'll review everything that happened. On the afternoon of the 13th of April 1993, the air above the province of Buenos Aires seemed charged with an invisible electricity. The fields, stretching out to the horizon, maintained a strange, almost expectant silence. The animals grew restless, the birds flew low, and the dogs barked incessantly. It was as if something profound, something impossible to name, was brewing above their heads. As the sun began to sink in the west, a dark line began to form on the horizon. The elders of the place knew that this color, this dense, almost metallic hue, bode ill. Within minutes, the wind shifted, and the air became sticky and still, as if the world had stopped breathing. A flash of lightning cracked the sky, and then another, and another. These weren't simple bolts. They were pulses of energy that illuminated the landscape with a white, spectral light. Each flash revealed a new shape in the sky, a wall of clouds that grew and swirled like a living colossus. It was the prelude to something gigantic. At 8 o'clock at night, the sky over northwestern Buenos Aires opened with a roar that rattled windows and shook the ground. Meteorologists would later describe it as a convective explosion. For those present, it was as if the firmament had exploded. In the ensuing silence, a deep, continuous sound was heard, like the passing of a train that never arrived. The first tornado had touched down. From Henderson to Urdanpilleta, witnesses reported the same thing. A column of wind swirling with impossible force, kicking up dust, trees, and fragments of everything in its path. Some saw it coming, illuminated by lightning. Others guessed it amid the roar of the storm. But they all agreed on one sensation. The air vibrated, and time seemed to slow down. The first was just the beginning. In less than an hour, new plumes descended from the clouds, almost in unison, stretching over a swathe of more than 200 kilometers. Some funnels were thin, barely perceptible. Others, wide and dark, moved like beasts searching for prey. Fields were carpeted with branches and sheet metal. Roads were littered with fallen trees. The lights in small towns flickered until they went out completely. In Pehuajo, a woman would recall years later the exact moment she heard the roar of heaven, a vibration that pierced her chest, followed by a silence so absolute it seemed supernatural. Then came the roar. The wind ripped the roof off her house and hurled it more than 100 meters away. She survived, clutching her children, as the gale faded as quickly as it had arrived. No one could have imagined that this was just the beginning. In the following hours, dozens of tornadoes would emerge in different parts of the province, as if the air itself had gone mad. From the Aziza weather radar, operators saw confusing signals, multiple echoes, shapes that multiplied too quickly. The technology of the time was not prepared to understand what was happening. The Argentine sky had become a mosaic of chaos. Lightning bolts illuminated simultaneous funnels, a dozen of them swirling simultaneously over the fields. It was a dance of destruction that no camera could fully capture. Weather stations collapsed, reports were mixed, and the wind, that wind with the scent of torn earth, continued to scream in the darkness. To understand what happened that night, we must consider a concept meteorologists are familiar with: a tornadic outbreak. In simple terms, it's a sequence of several tornadoes developing in a short period of time, all originating from the same storm system. In the United States, these events are studied and feared, but in the Southern Hemisphere, and particularly in Argentina, they are extremely rare. In most parts of the planet, tornadoes occur in isolation, like momentary eruptions from the sky. But an outbreak, as it's called in scientific jargon, is something else entirely. It's the result of an atmosphere that has reached such a high level of instability that it produces tornadoes one after another, without respite, as if nature had lost control of its own power. On the night of the 13th of April, 1993, that was exactly the situation. A gigantic supercell storm system stretched from southern Córdoba to the province of Buenos Aires, generating more than 100 tornadoes in just 6 hours. The magnitude of the phenomenon defied all known records. By comparison, even some historic outbreaks in the United States, such as the one in April 1974, with 148 tornadoes developed over a much larger area and with better monitoring conditions. In Argentina, on the other hand, no one was prepared. What made that outbreak so unusual wasn't just the number of funnels, but their distribution. Tornadoes appeared simultaneously in different parts of the world, separated by tens of kilometers but connected by a common storm structure. It was as if the atmosphere had woven a web of perfect violence. Each supercell, spinning on itself, gave rise to a new vortex. Some lasted minutes, others mere seconds, but the result was the same: chain reaction destruction. Subsequent meteorological records showed extreme values. The level of instability known as CAPE was extremely high, indicating accumulated energy in the atmosphere ready to be released. A mass of warm, humid air from the north collided with a cold front descending from the south, generating a stark contrast. Added to this was the strong winds at altitude, which created the shear necessary for the storms to begin rotating. It was a perfect combination, almost impossible to replicate. But there's something else. The geography of the Pampas Plains contributed to the phenomenon. The vast expanses without mountains or obstacles allow air masses to move freely, accumulating energy without dissipating. It's the same principle that turns the central United States into the famous Tornado Alley. That night, for a few hours, Buenos Aires became its southern counterpart. Most of the tornadoes recorded during the outbreak were classified as F1 to F3 on the Fujita scale. This meant winds ranging from 160 to 320 kilometers per hour, enough to uproot trees, overturn vehicles, and demolish weak buildings. Although not all of them touched inhabited areas, those that did left behind an unmistakable trail, debris-strewn roads, bent utility poles, and a silence that only dawn could break. Argentine scientists were baffled. Nothing like this had ever been documented in the southern hemisphere. Radar maps were rudimentary, and the network of observatories was limited. The magnitude of the outbreak could only be reconstructed years later, combining eyewitness accounts, photographs, and satellite analysis. It was then that the unthinkable was confirmed. More than 100 tornadoes had touched down between 8 p.m. and 2 a.m. A record, yes, but also a warning, because what happened that night demonstrated that Argentina, far from being immune to major tornado events, is part of one of the most active zones on the planet, a territory where the ingredients of atmospheric chaos can combine at any moment. Modern meteorologists still observe that episode with amazement. It was not an accident or a whim of the weather. It was a perfect manifestation of atmospheric physics, a storm of impossible conditions that, for a few hours, turned the Argentine sky into a laboratory of hell. In meteorology, catastrophes never occur by chance. Every tornado, every storm, is the result of a series of ingredients that combine with pinpoint precision. On the night of the 13th of April 1993, the atmosphere over central Argentina combined all these elements in a lethal mix. It was, literally, the perfect cocktail. For days, a tropical air mass had been rising from the north of the country, laden with humidity and heat. The air, saturated with water vapor, accumulated over the Buenos Aires plain like a dormant bomb. Temperatures were unusually high for the season, and the sky, although clear at the beginning of the day, had a hue that meteorologists call milky bright, typical of days with a high amount of potential energy. Meanwhile, from the south, a cold front was advancing strongly from Patagonia. Pressure maps showed a clear frontal line, which would cross the province during the afternoon. In the midair, winds accelerated and changed direction with altitude. At the surface, they blew from the north. At 500 meters, they blew from the west. And at high altitudes, they blew from the southwest. This variation, known as vertical wind shear, is one of the key drivers for a storm to develop into a supercell. A collision was inevitable. When both air masses collided over northwestern Buenos Aires, the atmosphere unleashed all its energy. Humidity from the north began to rise violently, and the cold air from the south acted as a catalyst. Within minutes, The sky was filled with convective towers, columns of clouds that climbed up to 14 kilometers high. On the primitive radars of the time, these structures appeared as dense, irregular patches. But what was actually happening was much more complex. They were tornado factories in full operation. Each supercell rotated on its own axis. Inside, updrafts and downdrafts intertwined in a precarious balance. Warm air spiraled upward, cooling and condensing into clouds that rotated at incredible speeds. As this rotation intensified, the funnel descended from the base of the cloud, seeking to touch down. This was the origin of the first tornado recorded that night, and then of those that followed. Subsequent satellite imagery revealed that, over a 6-hour period, the storm system spanned a stretch of more than 400 kilometers. It was a monstrous line of energy that moved slowly eastward, unleashing a series of near-simultaneous tornadoes. The interaction between surface and upper air winds produced such a volatile environment that any new convective cells had a high probability of forming a funnel. The magnitude of the phenomenon can only be understood by considering the atmospheric indices of that day. The Cape, a measure of the energy available for convection, reached values exceeding 3,000 joules per kilogram, a figure comparable to the large outbreaks in Oklahoma or Texas. Added to this was a humidity level above 70% and a surface temperature of over 25 degrees Celsius, explosive conditions for an autumn night in the southern hemisphere. Meteorologists at the time, without modern modeling tools, had little warning of what was coming. The warnings were confusing, the data incomplete. No one suspected they were facing a historic storm. What happened next would forever transform the way we understand extreme weather in Argentina. As the hours passed, the convective system grew until it occupied a large part of the central part of the country. The lightning was continuous, the thunder deafening. Each electrical discharge illuminated a new funnel descending from the sky. The atmosphere had become a perfect machine, driven by the thermal contrast and humidity, unleashing its fury with almost mathematical precision. It was 8 o'clock at night when the first funnel descended upon the fields of Henderson. At first, only a distant murmur could be heard, a deep roar that rumbled like thunder. Then, a gust of wind swept through the trees and raised a curtain of dust that covered the entire horizon. The townspeople looked west and saw a wide spiraling gray column approaching with terrifying slowness. It was the first tornado of the night, and the prelude to a nightmare. Minutes later, the energy contained in the atmosphere was fully unleashed. From Pehuajo to Bolivar, from Urdanpieta to Dairo, confusing reports began to emerge. A rotating cloud, a noise like a train, the sky on fire. Telephone lines collapsed, downed wires sparked above the flooded streets. No one could communicate, and no one understood that what was happening was not a simple storm, but a chain of interconnected tornadoes, deployed like an army of winds. At 8:30, lightning illuminated a sky crisscrossed by several simultaneous funnels. From the air, according to later satellite reconstructions, more than a dozen rotating cores could be seen active at the same time. Each one had the potential to wipe out an entire town. In less than an hour, the Buenos Aires plain had become a chessboard of chaos. In Henderson, the first tornado ripped off roofs, toppled windmills, and threw debris hundreds of feet. In Urdanpieta, a church lost its steeple as if it had been scythed. In rural areas, metal sheds were disintegrated by winds of over 250 kilometers per hour. The sound was deafening, a deep, continuous roar that made the ground vibrate beneath one's feet. At 9 o'clock, the outbreak reached its peak. Witnesses described unforgettable scenes. In Dairo, the sky turned emerald green, and for a moment, the storm lit up from within, as if breathing light. Shortly after, a new funnel descended slowly, swirling with sinister elegance before lashing at the edges of the town. Wooden houses were blown like leaves, cars were dragged several meters, and the air was filled with sharp fragments. In Pehuajo, residents tried to take shelter in bathrooms or under heavy furniture. Some prayed, others screamed. On the outskirts, a cargo truck was lifted and thrown into a field more than 100 meters away. Elsewhere, a windmill was reduced to a wreck of iron. Each lightning bolt that struck the earth revealed new columns of destruction swirling in the darkness. It was like watching a swarm of shadows dancing to the rhythm of thunder. Local radio stations broadcast intermittent messages. Severe storm over Pehuajo. Possible tornado. Cut power. The voices trembled. At the Ezeiza weather station, analog radars displayed multiple signals, reflected echoes that blended into one another. No one in Buenos Aires yet understood that more than 100 tornadoes were occurring almost simultaneously. Between 9 and 11 p.m., the phenomenon reached its maximum extent. Funnels multiplied along a line of storms nearly 400 kilometers long. The towns of General Villegas, Bragado, Azul, and Olavarria reported severe damage. In some places, rain fell horizontally, driven by winds that were impossible to resist. In others, the sky opened like a luminous wound, revealing for seconds the chaos that reigned below. At midnight, when many thought the nightmare was over, a new wave of storms crossed the southern region of the province. In 9 de Julio and Saladillo, the flash of lightning revealed columns of wind swirling over the fields, uprooting trees that had stood for decades. Animals ran aimlessly, and the lights in the towns flickered before going out completely. The night was plunged into total darkness, broken only by the sound of the wind. At 2 in the morning, the atmosphere finally began to stabilize. The exhausted supercells moved toward the Rio de la Plata. Silence gradually returned, but it was a silence filled with fear. In every town, makeshift sirens began to sound, searching for survivors. Roads were blocked, utility poles downed, and radios were muted. The dawn of April 14th was silent, almost unreal. Over the fields of Buenos Aires, the fog hung low, obscuring what remained of the towns battered by the previous night's fury. As the sun began to lift its light over the plain, the magnitude of the tragedy became apparent. Where once there had been roofs, there was now rubble. Where there had been trees, only uprooted trunks remained. And on every corner, the same expression on people's faces: disbelief. In Henderson, the streets resembled a battlefield. Neighbors walked among scraps of wood, bent metal sheets, and broken glass, searching for signs of life. Some held photos, others simply hugged each other in silence. The wind had torn away everything fragile, leaving a mark in its wake that would never be erased. It was like the heavens opened up and breathed in on us, one elderly man said, looking at his house, now a skeleton of bricks. In Urdanpieta, the church that had lost its bell tower became a makeshift shelter. There, the wounded arrived covered in dust and blood, staring blankly. Doctors and volunteers improvised stretchers with broken doors. The bells, fallen to the ground, lay silent, metallic witnesses to the disaster. The accounts were fragments of a single story: the roar, the hot air pushing against the walls, the silence that followed the destruction. In Dero, schools served as relief centers. The children didn't understand what had happened. Some wondered if the wind would come back for them. On the outskirts, the countryside had changed shape. Silos blown through the air were scattered across the land like broken toys. The rural roads were unrecognizable. Bent poles, uprooted fences, dead animals alongside the living. The landscape was an open wound. Local authorities, without communication or electricity, relied on police vehicles to coordinate aid. Shortwave radios broadcast distress calls. Pehuajo needs doctors. Urdanpieta without power. Henderson isolated. Each word carried an enormous weight. There was no national emergency system prepared for a catastrophe of this magnitude. The country woke up to the news that Buenos Aires had been hit by something few believed possible: a night of 100 tornadoes. Survivors recalled chilling details. One man recounted seeing his multi-ton tractor blow away like a sheet of paper. A woman recounted how the wind tore the door off her house and hurled it at a neighbor's. Another said the air whistled, as if it were alive. But perhaps most terrifying was the silence that followed, that heavy calm as the wind receded, leaving only the sound of wailing and creaking wood. In the smaller villages, where the houses were humble, the damage was complete. The tin-roofed homes disintegrated. Trees were uprooted, leaving craters in the ground. In some places, the tornado had spun with such force that crops had vanished, sucked into the funnel. Disoriented animals wandered among the wreckage, seeking shelter. Everything seemed suspended in a kind of broken dream. It took hours for the national media to fully grasp what had happened. The first images showed scenes that looked like something out of an apocalyptic movie. Overturned vehicles, Poles bent like thread, collapsed walls. Cameras showed neighbors cleaning the remains of their homes with their hands, searching for documents, photographs, anything that reminded them of life before the disaster. Solidarity, however, emerged immediately. Trucks arrived from neighboring cities with clothing, food, and volunteers. The tragedy had united everyone under a common sentiment: to help. In some villages, cemeteries didn't have enough space for the bodies. Families gathered around the rubble, praying or simply watching in silence. No one could understand how something so powerful had happened without warning. It was a matter of minutes, they repeated over and over. The sky roared, and then nothing. Amidst such devastation, stories of hope also began to emerge. A child found alive under an iron bed, a dog that led rescuers to its trapped owner, an elderly couple who survived, cuddled inside an overturned refrigerator. These were glimmers of humanity amid the chaos. As the hours passed, rescue helicopters began to circle over the area. From the air, the scene was overwhelming. Straight lines of destruction, as if invisible giants had crossed the province, tracing parallel scars across the land. It was the map of an impossible night, a night that would remain etched in Argentina's collective memory as the most ferocious ever experienced. The big question, after that night, was unavoidable. How was it possible that no one had seen it coming? How could the sky unleash such fury without prior warning? In the 1,990 seconds, Argentina lacked the meteorological infrastructure necessary to detect an outbreak of this magnitude. And that lack, more than technological, was also a lesson that would forever mark the history of meteorology in the country. In 1993, Argentina's weather radar network was minimal. There were only a few analog devices with limited range. The main one was located in Ezeiza, and its technology was from the 1,970 seconds. Those radars displayed images in shades of green and white on circular screens, manually interpreted by technicians. There were no colors, no precise resolution, and no automatic tracking systems. To detect a supercell, that monstrous tornado factory, it was necessary to read between the lines, to recognize almost invisible patterns in a sea of interference. The meteorologists on duty that night did their best. As the signals multiplied on the screen, they began to suspect something unusual was happening. But the system was slow. Communication with inland stations depended on unstable telephone lines, and many had been cut off by the storm itself. What in the United States would have generated an immediate alert translated into uncertainty in Argentina. There was no national early warning system yet. Warnings relied on bulletins issued by the National Weather Service, broadcast on radio or television. But the process was slow. From observation to publication, hours could pass. By the time the reports reached the media, the tornadoes had already done their work. Wind speeds far exceeded those reported. Added to this was a structural problem: the limited public awareness of tornadoes. In most of the country, these phenomena were viewed as rarities, not real threats. People didn't know how to react or where to seek shelter. In many homes, the tin roofs were lifted off at the first gust of wind, and residents went outside to look at the sky, unaware that the funnel could be deadly. The culture of prevention, so deeply rooted in regions like the American Midwest, was non-existent. The radar images recorded that night, which would be digitized years later, showed a terrifying sequence. The outbreak was not a single event, but a continuous chain of supercells stretching from northern La Pampa to the Rio de la Plata. However, the lack of precision prevented meteorologists from distinguishing each cell individually. From their perspective, the storm resembled a single gigantic mass. There was no way of knowing that, within that mass, more than 100 tornadoes were brewing. Official damage reports took days to consolidate. Some villages were cut off for more than 48 hours. Eyewitness accounts were the main source of information, and the reconstruction of the outbreak was carried out almost like a forensic investigation, comparing accounts, dates, photographs, and traces on the ground. Thus, little by little, scientists began to understand the magnitude of what had happened. The lack of technology wasn't the only cause of the disaster, but it was the most obvious. If Buenos Aires had had a modern Doppler radar capable of measuring wind speeds within storms that night, authorities could have issued accurate warnings in advance. But in 1993, such equipment was still a luxury reserved for large research centers abroad. The disaster of 1993 left deep scars, but it also ignited a spark of change. Argentina, a country accustomed to viewing meteorological phenomena as mere whims of the climate, began to understand that the atmosphere could be as relentless as any other natural force. The night of the 100 tornadoes became a symbol, a turning point between ignorance and awareness. In the months that followed, meteorologists, engineers, and officials analyzed the data over and over again. Radar images were studied frame by frame, pressure maps redrawn, and eyewitness accounts collected with almost scientific precision. What they found was clear. The country needed a revolution in the way it observed the sky. The first step was to modernize the radars. With the help of national scientific institutions, projects were initiated to install state-of-the-art Doppler equipment capable of measuring wind speed and direction in real time. For the first time, Argentina could see inside storms, detect rotations, issue accurate warnings, and anticipate severe weather. The country began building its own meteorological defense system. The tragedy also prompted the creation of communication networks between the provinces and the National Meteorological Service. What had previously been isolated reports became a coordinated flow of information. Geostationary satellites, which in the early 1992s were remote tools, became part of daily monitoring. In a short time, the country began to forecast more accurately and, above all, to provide early warnings. But the most profound lessons were not limited to science. In rural schools, teachers began teaching what to do during a severe storm. Evacuation drills, awareness campaigns, and local contingency plans were promoted. The idea was simple. A prepared population can survive what an unprepared population cannot. A culture of prevention, almost non-existent in the 1992s, began to take shape. At the international level, the scientific community watched the events with interest. The Buenos Aires outbreak demonstrated that the southern hemisphere had its own tornado zone, a corridor stretching from northern Argentina to Uruguay and southern Brazil. Studies, collaborations, and comparisons with the North American tornado alley multiplied. What had once been a rarity became a serious and necessary field of research. In parallel, the affected municipalities began to rebuild not only their homes, but also their identity. Each town planted new trees, built reinforced schools, installed sirens, and built underground shelters. In Henderson, a bronze plaque commemorates the victims and thanks those who helped. In Pehuajo, the community erected a monument with fragments of twisted metal collected after the storm, a way of transforming grief into memory. Over time, the episode became a recurring warning. Every time the sky darkens and the wind blows from the north, the people of Buenos Aires remember that night. Meteorologists, for their part, watch the radars with respect. They know that the atmosphere can repeat itself, that the same ingredients could mix again. But they also know that today the country is better prepared. New generations of Argentine scientists grew up with that story. Some, inspired by the images and stories of 1993, decided to dedicate themselves to studying severe storms. Thanks to them, Argentina became a regional benchmark in the study of supercells and microbursts. What began as a tragedy transformed into scientific momentum. 30 years later, as the wind blows strongly across the pampas and the horizon turns gray, a new generation looks at the sky with a different perspective, no longer as an enemy, but as a teacher who once displayed his absolute power. The night of the 100 tornadoes lives on, not only in the memories of those who survived it, but in every warning system, every school drill, and every scientific decision that seeks to prevent history from repeating itself. The night of 100 tornadoes reminds us that nature is powerful, unpredictable, and sometimes terrifying. But knowing, studying, and preparing gives us an advantage over its force. If you want to continue exploring extreme phenomena, hear shocking stories, and learn how the wildest forces of the weather are unleashed, don't forget to subscribe to Extreme Tornado. Activate the notification bell so you don't miss an episode and join us on this adventure through the most violent skies on the planet. Because here, every storm has a story to tell, and every story deserves to be heard.